This is Unit 13, Properties of Solutions, Video 13.4, the solution process. When a solute dissolves in a solvent, it's generically called solvation. However, if the solvent specifically is water, then we use the term hydration. Let's take an example of a salt, we'll say calcium chloride, that dissolves in water. One of the things we've practiced in the past is writing dissociation equations, and we can show that the calcium chloride comes apart and it produces one calcium ion and two chloride ions. Take a look at figure 13.1 on page 529 in your textbook. Examine these three pictures closely and you'll see the solvation process. A very common question on the AP exam will be for you to graphically depict what's happening in the solvation process. What they want to see is this. For each calcium ion, you have two chloride ions. And then the second part of this depiction will be to put the positive side of the water molecule, that's the hydrogen, next to the negative chlorine. So to get full credit for this question, they're going to have to see twice as many chloride ions as calcium ions, and they need the positive hydrogen next to the chloride ions. And then the calcium ion, since it's positive, is going to have the negative side of the water molecule, that's the oxygen, next to the calcium ion, like so. Solvation and hydration refer to a solid dissolving in a liquid. What about two liquids dissolving? Let's say alcohol and water. That would be miscible. If two liquids do not dissolve in each other, for instance oil and water, we say they are immiscible. Number 5. The solvation process actually occurs in 3 steps. In the first step, it takes energy to pull that salt apart, for instance to produce the calcium chloride ions. This process is going to be endothermic. Then it takes energy to pull the water molecules apart. That's also endothermic. And then when the water molecules move in and surround the ions, that part is called, or would be, exothermic. So collectively, these 3 steps together combine to determine whether overall solvation is exothermic or endothermic. Let's advance the page and I'll give you 2 examples which we will see in class. If you dissolve sodium hydroxide in water, it's a very exothermic process. As a matter of fact, when I make a 1 molar solution of sodium hydroxide, I usually surround the graduated cylinder with ice because it's so very hot. On the other hand, if you put potassium nitrate in water, it's very endothermic. It's very cold. Let's advance to number 8. Both of these processes are spontaneous for different reasons. In order for a process to be spontaneous, one of 2 things or both must happen. So overall, the energy of the system must decrease. Most exothermic reactions are spontaneous, or entropy must increase. Entropy is disorder. For instance, if you took a deck of cards and you scattered them around the room, that would be an increase in entropy. So this is a topic which we will cover later on. For now, just remember that you must have at least an exothermic reaction, or entropy must increase dramatically, or a combination of both in order to be spontaneous. And let's advance to note number 9, and the last part of this lesson will be solubility and the 3 factors which will increase the rate of solubility. In a later on lesson we'll talk about quantitatively about solubility. Right now we just want to speed it up. One of the things we can do obviously is we can heat the solvent. If you want something to dissolve in water, you can just heat it up. Another way to increase the rate of solubility is to increase the surface area. You can grind it and you can chop it up. For instance, a sugar cube is not going to dissolve nearly as fast as granulated sugar. And the last thing you can do is just stirring or mixing. That just brings the water molecules in contact with the ions much faster. And that's the end of video 13.4, the solution process. Go to Moodle and look at questions 13.4 and answer them at this time.